Hello everyone and welcome back to Math 127 Pre-Calculus 2. So in our previous lessons, we have learned how to graph sine and cosine functions and how to analyze their transformation using the amplitude, period, the phase shifts, and the vertical shifts. So today we are going to complete our study of six trigonometric functions by exploring the graphs of tangent, cotangent, secant, and then cosecant. So you may notice that our textbook present a separate graphing procedure for some of these functions. While that approach is definitely correct, I will just be continuing using the process that is similar to the one I've used when graphing sine and cosine function. So again, I just want to keep the consistency of the presentation of graphing all the six trigonometric functions. So rather than memorizing completely different set of graphing steps, so we will continue identifying the period, like I mentioned, phase shift, vertical shift, key points, and asymptotes when needed. So this allows us to build on concept we already understand and helps us see the connections among all those six trigonometric functions. Okay, so now let's go ahead and begin with the tangent function. All right, now before graphing the tangent function, let's first understand what makes the tangent function different from sine and cosine. Now, recall that, okay, let me use this space, okay. So recall that tangent, let's say for example, tangent theta, the definition for this one in terms of sine and cosine is sine theta over cosine theta. Okay? Since cosine theta appears in the denominator here, the tangent function becomes undefined whenever the cosine theta equals 0. Okay? Now, when do we know that the cosine theta is equal to 0? We know that, for example, if this is the x and y coordinate, we know that cosine theta is 0 if, for example, the point is located either on positive side of the y values or the negative side of the y value. So, for example, I'm just going to go ahead and apply the point coming from the unit circle. So we have here a 0, 1, and then we have here a 0, negative 1. Okay. Now, if you notice, once again, if I'm going to rotate the terminal side, so as you can see, we do have there a 90-degree angle, which is the pi over 2. Now, if I'm going to rotate this with another 180 degrees, which is a pi in radian, then therefore, we have there another x value or cosine theta which will become a 0. Okay, so if that's the case, therefore, we can now say that the tangent function here is undefined at pi over 2. Okay, those pi over 2, it's like an increment or multiples of pi over 2. Okay, all right. Now, since what do you call this? Now, this would create definitely if we have there that the tangent function is undefined at x equals pi over 2. This creates something new that we have not seen in other three graphs, which is now what we call the vertical asymptotes. Okay. Now, as we study the graph of pay attention to where these asymptotes occur and how they affect the shape of the curve. Okay, so as you can see here on the illustration, we do have those vertical asymptote, which are the vertical line definitely, which is at x equals negative pi over 2 or pi over 2 and then an increment of again pi, which is one period for tangent. Okay, so remember the period is tangent. Okay, all right. Now, The characteristic of a tangent function. Let's just go. Okay, let's proceed. Oops. All right. So for the characteristic of the tangent function, we have here the period, which is the pi. As you can see here, that one full period here is from the this first asymptote up to the next consecutive asymptote. So with this, we already have one full period here. Okay. So you notice that one full period here that gives you a total of pi. And then of course the domain here, it will always be definitely all real numbers except the location of the asymptote. And we know that the location of the asymptote would be the odd multiples of pi over 2. Just like in this case, we have the negative 5 pi over 2. It's an odd multiples of pi over 2. We have a negative 3 pi over 2, negative pi over 2. We have pi over 2, and so on and so forth. Okay, and then for the range, as you can see, they are extending upward and then downward infinitely, so therefore the range would be all real numbers. Okay, and then remember that the tangent function, we say that this is an odd function, which is once again an odd symmetry. All right, that means to say that if you're going to reflect this graph over the origin, now it will give you exactly the same location of the point. And then again, of course, those vertical asymptotes, which are the multiples of odd multiples of pi over 2. Okay, all right. Moving on to now for the vertical asymptote, we already have mentioned that the odd functions there, and then also that we do have here the x-intercepts. Okay, so the x-intercept, that would be the midway between the two consecutive asymptote, and then of course the odd function with the origin of the symmetry. Okay, so let me go ahead and move on. Alright. All right, this is what our textbook is providing us. That again, we do have here step number one. We are computing for the consecutive asymptote through this given inequality, okay, which is a compound inequality here, which is we will start from the negative pi over 2 to pi over 2. So if I'm going to go back with the graph here, this is the part here that we are going to use as our key points. Okay, all right. So and then we just simply completely isolate the variable x here so that we will know the two consecutive asymptote. And then for step 2 and then step 3, instead of following these two steps here, I'm going to do exactly the same process, just the way we did from sine and cosine function. Okay, so this is how one period of tangent function looks like. Okay, now let me go ahead and move on with the example. Okay, now let's go ahead and work through this given example. Given that you have the y is equal to 3 tangent um, 2x for the negative pi over 4, and then less than x less than 3 pi over 4. Okay, like I mentioned, I am going to follow similar process when we were graphing the sine and cosine function. Okay, so I'm gonna go start by finding the first two consecutive asymptote. Okay, so this would be my first step, two consecutive asymptote. Okay, two consecutive asymptote. So in this case, we say that okay. Okay, we say that that is from negative, we will start from negative pi over 2 less than, and then all we need to do is to use this input here from the tangent function, which is 2x, and then less than pi over 2. Okay, once again, why are we using this? I have shown you the picture of the, again, a portion of the parent function from the tangent function. Okay, so, and like I mentioned, we need to completely isolate the x here by dividing all parts of the inequality here by 2. So, dividing this by 2, and then I'm going to divide this also by 2, and then by 2. When I'm say dividing and then you're working with fraction, that would just mean you are just literally multiplying that value in the denominator. Okay, so now we have here um, negative pi over 4, and then less than x, and then less than pi over 4. Okay, now with this, we are now able to find the asymptote, which would be, okay, I will name the first asymptote that I have here would be x sub 1, which is equal to negative pi over 4. And then the other one is x sub 2, which is pi over 4. Okay, next step, I am now going to identify that one period. Okay, the measurement of that one period. So now I have here, for the period, how we are going to solve that, definitely we will just be finding the distance between the two asymptotes. So meaning to say I will just subtract that from the first asymptote. So we have there x sub 2 minus x sub 1. So we have pi over 4 minus the negative pi over 4. So in this case, we have now pi over 4 plus pi over 4, which gives us 2 pi over 4, which is once again simplifying this would be pi over 2. Okay, all right, next up we are now going to identify the increment. We know that when I say increment, remember that this is the value that is being added repeatedly to find the x coordinate of each of those keys. Okay, so now we know that we are looking for the increment by dividing the period by 4. So this is now pi over 2 over 4, which gives you pi over 2 times the reciprocal of the denominator 4. So that's going to be 1/4. So this is now pi over 8. Okay, so this is now our increment. Now I'm going to go ahead and move on and identify now at least 5 keys, okay, or the key points. And then definitely these are not just all points, but we do have here the vertical lines, which are the vertical asymptote. Okay, so I'm just gonna go ahead and name it as the fourth step here, which will be the keys. And like I've said, you give at least 5 keys. All right. Okay, and definitely the first key here would be our first asymptote that we have solved. So that's gonna be, we have here x is equal to negative pi over 4. Okay, this is coming from the first asymptote. And then I'll be using the same value here from x, which is the negative pi over 4. And then I'm going to add our increment here, which is pi over 8. Okay, so I'll just be adding that repeatedly over and over again. Okay, to complete our 5 keys. Okay, so plus pi over 8. So this would be equal to negative pi over 8. So this is our first point within those two asymptotes. So this is negative pi over 4, sorry, negative pi over 8. Okay, and then the y value here, okay? So remember, in this case, since we do not have that what we call the amplitude, obviously, if I'm going back with the graph here, Okay, that first point within that two consecutive asymptote would be this point right here. So where do we start? It would be below the midline. Okay, so if you have a coefficient 2, so below midline here would be the negative 2. If you have a coefficient 3, then therefore below midline here would be negative 3. So what do I mean that coefficient? Okay, so that coefficient, I meant that coefficient in front of the tangent function. In this case, it is 3. So therefore, I'm going to have a y value there, which is a negative 3. Okay, and then going up. So remember, this is increasing everywhere. So we have now the previous x coordinate is negative pi over 8. Now I'll be adding that increment pi over 8. So now this is equal to 0. So now we have here 0. And then remember, it's going up. Okay, this is where we got the negative 3. And then in the midline here, that would be a 0. Okay, and then going up there. Okay, and so now, again, the x value is 0 plus pi over 8. So this would now be, again, pi over 8. Oops, that is equal to pi over 8. There should be equal sign only. Sorry about that. Okay. Pi over 8. Okay, so now this will give us pi over 8. And then going up over here, okay, over here, so that's going to be positive 3. Okay, all right. And so now the last key here would be definitely our key points, but I'll continue adding that increment pi over 8. So pi over 8 plus pi over 8, we know this is 2 pi over 8. Simplified form, this is pi over 4. Okay, so which is again our this is the second um, asymptote, which is at x equals pi over 4. Okay, right, which makes sense, isn't it? The second asymptote here is pi over 4, which complements our fifth key. All right, so now since I already have those key points, I will now be going to graph the function. Okay, just okay, I'm just gonna go ahead and draw below here. Okay, so we have 1, 2, 3. Okay, so we have here 3. Oops. And then we have here negative 3. And then our points here, we do have the pi over 8, the multiples of pi over 8, and then negative pi over 4. Okay, and then we have here pi over 4. What else? We have here, okay, and then pi over 4 plus pi over 8. Okay, we have here 3 pi over 8. And then we have pi over 2. And then 5 pi over 8. And then plus 3 pi over 4. Okay. All right. Now how I got those points, definitely, I just keep on adding our increment, which is pi over 8 from each of those values. Okay. All right, now I'm gonna go ahead and start drawing the asymptote, wherein the asymptote are at x equals negative pi over 4. And then the other one is at x equals pi over 4. Okay? And then plotting the points, the first point here would be at negative pi over 8 and then negative 3. Okay? Negative pi over 8 is right here and then negative 3. All right? Next point right here is at 0, 0. So now we have at 0, 0. And then the next point here is at pi over 8 and then positive 3. Okay, so and then now connect that point, making sure that we are again drawing exactly the same shape as a tangent function. Okay, now I already know the shape or the pattern of the behavior of this given function. I'm just gonna go ahead and continue it to the right, since according to the problem we wanted to graph this from negative pi over 4 until 3 pi over 4. Okay, so now I do have here an asymptote. Okay, so we have here the point and then the midpoint, and then we have here another point going up. Okay, all right, so there you go. This would now be our graph for the first function. Okay, now I'm gonna go ahead with the next um, function, which is what we call the cotangent function, which is the reciprocal of tangent function. Okay. All right, now once again, let's take a look at the cotangent function. Now, once again, recall that the cotangent function, the definition is cotangent theta is equal to cosine theta over sine theta. Okay, now where the vertical asymptote here would be wherever the denominator here or the sine theta, that would make it again equal to 0. And then remember the y value on an x and y plane, what makes it a 0. So that would mean if it is along the x-axis, right? Let's just say I'm gonna go use the points on the unit circle. If this is 1, 0, and then this is negative 1, 0, obviously we see here a value of y which are equal to 0. And remember, the y coordinate here is associated with the value of sine theta. Okay, so now with this, so what are the values there? So the values there would be if it is initial side, terminal side, and then therefore that would be an angle that is a 0 angle. Yeah, and then also if we have here, if we're going to rotate that terminal side on this side, this would be once again that angle pi. All right, so 0 and then pi, and then once again if you are going to rotate that once again with a pi, you'll go back when y is equal to pi. Okay, so once again, since sine is now the denominator, cotangent becomes undefined whenever sine equals 0. So like tangent, cotangent contains vertical asymptotes. However, one major difference is the direction of the graph. Okay, so as you can see here, from the tangent function, it is increasing everywhere, but in this case, the direction is decreasing. Okay, so it is decreasing from left to right. All right, so again, the tangent curves, like I've said, it increases from left to right, while the cotangent curve decreases from left to right. So as we study the graph, focus on comparing it to the tangent graph and identifying both similarities and the differences. So we will be exactly doing the same step, just like what we did from the previous function. Okay, now let me go ahead with the properties here. Yeah, okay. So these are the characteristics of a cotangent function. You notice it has a similar characteristic with a tangent function, but like I've said, um, uh, except for the direction of the graph. Okay, so again, we do have here the period. It's the same thing as the cotangent, which is pi. And then for the domain, in this case, the domain here, as you can see, the vertical asymptote here is located at x equals 0, x equals pi, or x equals 2 pi. So that means to say it's the multiples of pi. Okay, and then the range, it's all real numbers because as you see, it's increasing infinitely and decreasing infinitely, okay, continuously. So, and then the symmetry as well, and then also the asymptote. We already went over with that one, okay. All right, so next up, so we now have to, okay, go ahead with the example here. All right. So just as we transform the tangent function, we can also transform definitely the cotangent function. So the graphing process, like I mentioned, is very similar. So we will identify the period, determine the important x and y values, and then we are going to graph them. Okay, and then definitely you have to locate the asymptote, and then after that we can sketch the graph. So as you work through the example, notice how the graph decreases rather than increases. Okay, now let me go ahead and move on. So as you can see here, it is decreasing from left to right. Okay, so now given here the example, the function y is equal to 1 half cotangent pi over 2 x. Okay, so in this case, first thing that I will do is to definitely apply the identification of the asymptote. And unlike with the tangent function, if you notice, we are using from negative pi over 2 to pi over 2. In this case, we are going to use from 0 to pi, okay? Just like what we have here from step number 1. It's from 0 to pi. So you have to remember that this is applicable with cotangent. Okay, the negative pi over 2 to pi over 2, that is applicable for tangent. So, next one. Okay, let's go ahead and continue. So, like I mentioned, we will start from 0. And then we have here that pi over 2. And then x to pi. Okay. All right. So, next we now completely isolating the x variable here by multiplying everything by the reciprocal of pi over 2. So we know that the reciprocal of pi over 2, let me just, okay. Okay, reciprocal of pi over 2 is 2 over pi. Okay, the reason why we are multiplying its reciprocal so that we can make that pi over 2 equal to 1. So this is 2 with pi. So we have here, definitely this would just be equal to 0. And then less than, this cancels out. So there you go, we only have x. And then here, the pi cancels out as well. So we only have equal to 2. So our asymptote here would be equal to 0. And we have x equal to 2. Okay, so those are the first two asymptote that we have. All right, so now we now proceed with identification of the period. So once again, the period would be x2 minus x1. So x2 is 2 minus 0 is also 2. Okay. Next, I will now proceed identifying with the increment. So like we mentioned, increment is just simply period divided by 4, which is equal to, period is 2 over 4. So now we have an increment of 1 half. Okay, and then, okay, lastly, we now proceed with the keys. All right. Remember, for the keys, we need to have at least 5 key points. Okay. So for first point, first key, second, third, and then fourth, and then fifth. Okay. So the first key here would be, of course, our first asymptote, which is the x equals 0. Okay, I got this from our first asymptote. Now, second, third, fourth are the points between the two asymptotes. Okay, so in this case, we have here, remember this is an asymptote. That is why I have written it as x equals 0. Okay, next is the first point. So we will have here that 0 plus the increment 1 half, so therefore, this is 1 half. So therefore, the point here is at 1 half. And then you have to recall that the graph of a cotangent function is decreasing. So therefore, we are going to start there from top going down. Okay, so therefore, the y value here would be definitely the coefficient in front of the cotangent, which is 1 half. And then here is 1 half for the y, and then here definitely is a negative 1 half for the y coordinate. Okay, all right, so now for the third point here, I'm gonna use the previous x value, which is 1 half, and then plus 1 half, which is the increment. So this is now 1, so this would be now our middle point, which is 1, and then again going down, so that's gonna be 0. Okay, and then fourth point here would be 1 plus 1 half. So therefore, this is 3 over 2, which is once again 3 over 2. And then this is going to be negative 1 half, which is this point right there. Okay, and then last key would be our asymptote, which is again 3 over 2 plus 1 half. As you can see, this becomes 4 over 2, or simply 2. And that makes sense, isn't it? Because again, from the previous identification of the asymptote, we have found that the next asymptote should be x equals 2. And it's indeed x equals 2 also on this process, okay, which is again the second asymptote. All right, so now since I already have all the keys I need here, I can now start graphing this. According to the instruction here, they want us to graph this with 2 periods. Okay, so remember this is only 1 period, so I need to extend that either side. Okay, either you want to extend it on the left side or on the right side. Okay, so now I'll have here 1, 2, 3, 4. Okay, so the first point here would be, of course, 0 there, and then next is 1 half, and then next is 1, and then 3 over 2, and then 2, and then we have there the 2 plus 1 half is we have 5 over 2, plus 1 half is 3, and then plus 1 half is 7 over 2, plus 1 half we have there 4. Okay, all right, so now let's go ahead and begin graphing the asymptote first. Okay, so the asymptote is at x equals 0 over here, x equals 0, and then we have the next asymptote is at x equals 2. Oh yeah, also we need to have that y grids here. So we have here 1 half, we have here negative 1 half. Okay, all right, let's start plotting the points. We have here the 1 half, 1 half. Okay, 1 half and then 1 half, and then we have 1 0, and then 3 over 2, and then negative 1 half. Okay, so as you can see here, it's going down. from left to right. Okay, so since I now have the shape here, I can just follow that, the same shape, for me to extend the graph, okay, to achieve the requirement of the problem having two periods. Okay, so there you go. Okay, so this is now the graph of the second function. Okay, all right, now moving on to, okay. So now let's go ahead and move on with another example for the cotangent function. But for this given function, we are going to transform this or slide this um, horizontally. Okay, so we're going to slide this horizontally since we do have here, what we see here is a phase shift. All right, since we do have a value for C. Okay, all right. So again, our graph here, we are expecting that the graph here will be moved to the left, okay, to the left by pi over 4. Okay, as you can see there, remember, this is x minus c. So when you are to substitute the value for c, I mean, it's not yet for the cotangent, but remember, if you are to substitute this value in the value of c, you have to make sure that the c value is negative pi over 4. Okay, so we will see that in our process here when graphing this function. Okay, so again, since this is a cotangent function, the asymptote here would be from 0 to pi. Okay, so I'm gonna go ahead and use that 0. Okay, 0, and then it's x plus pi over 4, and then 2 pi. Okay, at up to the pi. All right, so now I will be subtracting all those parts by pi over 4, negative pi over 4. Okay, so now with that, we have here a final inequality, which is pi over 4, and then x, and then we have 3 pi over 4. Okay, I am solving the asymptote here, the two consecutive asymptote, okay, which is the first step. So therefore, the first asymptote here is pi over 4, and then the next asymptote would be 3 pi over 4. Okay, all right. So next, after identifying the first consecutive asymptote, we now identify the period and then the increment. Okay, we know that the period is x2 minus x1. So x2 is 3 pi over 4 minus pi over 4, which gives us the 2 pi over 4. Okay. Oh, hold on. I'm sorry. This is negative. Okay, so negative. So therefore, I must have a negative sign there in front. Okay, so therefore, this will now becoming 3 pi over 4 plus pi over 4. Okay, so this is now 4 pi over 4, which gives you just simply pi. Okay, now finding the increment here. Okay, this is the second step. Okay, third step, increment. So increment is simply period divided by 4. So we know period is pi divided by 4. So there you go, pi over 4 is already in simplest form. Okay, now fourth step, we'll go ahead with the keys. Okay, now for the keys, like I mentioned, we need to have at least 5 keys. And since we are working with cotangent, remember that our starting key here would be the first asymptote, which is at x equals negative pi over 4. And then, of course, we need to end up with another asymptote, which is the 3 pi over 4. Okay, let's see. We'll have here negative pi over 4 plus the increment pi over 4. This would now be equal to 0. So therefore, the first point inside those two consecutive asymptote, which will be at 0. And then you have to remember this is cotangent. So we are starting above the bit line. So therefore the y value here would be 5 and then going down. Okay, so now we have here 0 plus pi over 4 is equal to pi over 4, which now gives you a pi over 4 going down, which is 0. And then next, pi over 4 plus, again, increment pi over 4, which gives you, again, 2 pi over 4, which is simply pi over 2. With that, you now have here pi over 2 and then negative 5 since it's going down. Okay? And then lastly, the fifth point here is, again, pi over 2 plus pi over 4, which gives you 3 pi over 4. With that, since like I mentioned, the fifth key here is an asymptote, wherein this is now x is equal to 3 pi over 4. Okay, now I do have now the complete key here that I need in order for me to see the shape of this function. Now let me go ahead and graph this. Remember the requirement of this given graph here, we should be graphing two periods. Okay, so two periods. Let me go ahead now and graph this. Okay. Again, in your case, for example, if you're doing this on an exam, remember you can extend it since there's no given interval here. You can just create your own part of the coordinate plane, whether you want to extend to the right or to the left. Just make sure you are showing two periods. Okay. So we have there that negative pi over 4. Let me just do that one. Two. Okay. And then we have 5. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right. So now we have a negative pi over 4. We have 0 and then pi over 4. And then we have here pi over 2. I am writing with multiples of pi over 4. Okay, so now we have here 3 pi over 4. Okay, so two periods. So we'll have here 1, 2. Okay, so now we have here pi. Next we have here 5 pi over 4. Next we have 3 pi over 2. And then we have here 7 pi over 4. Okay. All right. So now we are going to plot the points. I'll start with the asymptote first. Okay. Asymptote are at x equals negative pi over 4. And then x equals 3 pi over 4. And then plotting the points, we have the 0, 5. So 0 and then 5. And then we have here pi over 4, 0. And then we have pi over 2, and then negative 5. Okay, so this is now the first curve. Oops. Okay, now since I know the shape now, I'm just going to go ahead and follow exactly the flow of the graph here. So we have here pi and then 5 and then pi, and over here and then down here. And then this would be now our asymptote. Okay. Let me just go ahead and fix that graph. Okay, just want to make sure I am also emphasizing those curved lines. So, okay, there you go. So this would now be the graph of this given function. All right. Okay. Now moving on to. Okay, So let's move on with the graphs of the cosecant and secant function. Okay, so the next two functions are different from tangent and cotangent because they are reciprocal functions for the sine and then cosine. Okay, so recall that cosecant x is just simply 1 over sine x. And then if we have that secant x is equal to 1 over cosine x. So rather than creating, again, graph completely from scratch, we can use the graphs of sine and cosine as guides. So this is one of the reasons why understanding of sine and cosine thoroughly is so important, okay? So as you will see, the graphs of secant and cosecant are built directly from the graphs of, we already know, from the sine and cosine function. Okay, now let's go ahead and begin with the cosecant. Okay, so because cosecant is the reciprocal of sine, so every place where sine equals 0 becomes vertical asymptote or of cosecant. Okay, that means to say those are the x intercepts under the sine function. So the graph will never cross this asymptote. So instead, we will see a series of upward and downward branches surrounding the sine curve. They look like a parabola. Okay? So as we graph cosecant, think of it as a transformed version of a signed graph rather than an entirely new graph. Okay? So in this case, since these are the reciprocal of sine and then cosine, we see that the period is 2 pi. The domain would be all real numbers except the integral multiples of pi. And then for the range, it will also be all real numbers except from -1 to 1. Okay, so as you can see here from the illustration, this shape that look like a parabola, those are the graph of a cosecant function. And this dotted line here are the graph from the sine function. So like I mentioned, instead of graphing an entirely new graph, we are going to use sine function as our guide to graph either cosecant and secant function. Okay, so definitely we will go back with exactly the same step, the way we did with, again, with the sine function. Okay. All right. And then finally, we do have here again the secant function. So remember that the secant function is the reciprocal of cosine. So just as we use the sine graph to create the cosecant graph, we will also be using the cosine graph to create secant graph. So the process is actually nearly identical. All right. Where cosine equal to 0, secant becomes undefined. Therefore, those are the location of the vertical asymptotes. So once we identify those asymptotes, the graph becomes much easier, of course, to sketch, as you can see here from the illustration. Okay, all right. Now let's work on with the following example. Okay. Okay, so like I mentioned, as you can see here, we do have here two functions that look like identical. It's just that this one is sine, the other one is its reciprocal, which is the cosecant, and then the rest are exactly the same thing. So what I'm going to do is I'm going to graph the sine function before the cosecant function. So definitely I'm going to follow exactly the same step from the previous lesson, which is the section 4.5. Okay, so I'm gonna go ahead and start with solving with the amplitude. We know that the amplitude, that is the coefficient in front of the function. So in this case, there's the amplitude here is simply 1. So there you go, it's 1. Okay. All right. Now the period. We know that the period is equal to 2 pi over b. And we can see here b as well. Here is just simply 1. So there you go. So 2 pi over 1. So we have here 2 pi. Okay. And so since we have here the period, we now move on with the increment. So we have here that would be 2 pi divided by 4, which is period divided by 4, which gives you pi over 2. Next would be the phase shift. So phase shift is C over B. We see that we have here the value for C. In this case, it's pi over 4. Like I mentioned earlier, it needs to be its opposite sign. Okay? So therefore, this is negative pi over 4 over B, which is just simply 1. So therefore, this is negative pi over 4. Okay? Now let's proceed identifying the keys. Okay, so the first point, second, third, fourth, and then fifth point. Okay, so the first point would be definitely, well, originally we are starting at 0, okay, for the sign. But since we have here a phase shift, so we are going to add that phase shift pi over 4. So therefore, this is negative pi over 4. Therefore, we are starting at negative pi over 4. And then remember, sign starts at 0, 0, okay, at the midline. So therefore, negative pi over 4 and then 0, which is the midline. Okay, next, negative pi over 4. And then the phase increment of, here you go. Let me just encircle that, okay, for the increment. So pi over 2, which gives you a value of pi over 4, which is again, that would be pi over 4. And then remember, sine function looks like this, okay? So we started with at 0, 0, and then going to maximum point, and then we'll go back at 0, and then minimum point, and then we'll go back to 0. Okay, so these are the points that we are looking for. All right, so we're done with this point. Okay, now at the maximum level, so we know that the amplitude is 1, so I'm gonna go ahead, maximum point, maximum value is 1. Okay, next, so pi over 4 plus another 1/2 here, so that gives us a 3 pi over 4, which is again 3 pi over 4. And then comma, this point right here, 0. Okay, at the midline. Okay, next, fourth point, we have here 3 pi over 4 plus the increment pi over 2 is equal to, we have 5 pi over 4, which is again 5 pi over 4. And then going down here, that's going to be negative 1. All right, next we now have 5 over 4 plus pi over 2. This would be equal to 7 pi over 4, which is again 7 pi over 4. And then going back on that point, so that's going to be 0. Okay, so those are now our key points. Now let's proceed graphing this since we have those information. Okay, so as you can see, there's no difference from graphing this sine and then cosecant, okay, in terms of the procedure. Okay, so we have here this point, 1, 2, 3, 4, 5. Okay. All right, so plotting the point, we have here at negative 4 and then 0. Okay, so let me write those values first. So this is negative pi over 4. This is pi over 4. This is 3 pi over 4. and then 5 pi over 4, and then 7 pi over 4. Okay, so now these are, of course, these are 1, negative 1. So we starting at negative pi over 4 and then 0, and then going up, then down, down, then up. Okay, so this is now the graph of the sine function. Okay, so how are we going to graph the graph of its reciprocal, which is the cosecant function? All you need to do is to draw those vertical asymptote at x-intercept. So these are the x-intercepts. Okay, x-intercept meaning to say those are the points on the x-axis. So these are the asymptotes of the cosecant. And we are going to use the maximum point and then the minimum point. The maximum point will have a curve opening upward. And then the minimum point will have the curve opening downward. Okay? So those green lines belongs to the graph of the cosecant function. And then of course the blue line belongs to the graph of the sine function. Okay, so there you go. This is the graph of this given function, sine and cosecant. Okay. All right, now we'll proceed with the next example. So next example, graph the y equals 2 secant 2x. Okay, so we do have here a given interval. So we are going to limit our graph within this interval. Okay, so like I mentioned, instead of drawing the secant from the scratch, we are just going to graph the cosine. Okay, we are going to graph the cosine as our guide. All right. Okay, so I'll start by identifying the amplitude. So amplitude. Okay, so amplitude here, we have here 2. So absolute value of 2 is 2. Okay, next we now proceed with the period. Period is, again, 2 pi over b. And we do have value for b here, which is 2. So 2 pi over 2, which is just simply pi. And then we now have here increment, where the increment is equal to period over 4. Okay, and as we can see here, period is pi and then over 4. So that would be our increment. Okay, next we now proceed identifying the keys. So the first point here, I did not identify the phase shift anymore because we do not have value for C anyway. All right, so the first key point here would be at 0. So therefore, the point here is at 0. And then remember, the reciprocal of secant is cosine. And then remember the parent function for the cosine, we are always starting at the maximum point. Okay, so since the value for the amplitude here is 2, so therefore the maximum point is 2. Okay, and then second point, we now have here 0 plus the increment pi over 4. This is now pi over 4. And then remember the graph of a cosine function would look like this. Okay, so we do have here maximum point, midpoint. Okay, I mean the point on the midline, and then the minimum point, and then point on the, oops, the point on the midline, and then going back to the maximum point. Okay, all right, so therefore we're okay with this now. So I want to draw the point on the midline, so therefore that is y is equal to 0. Okay, third point, we have pi over 4 plus the increment pi over 4. So that's gonna be equal to, again, 2 pi over 4, so that would be pi over 2. and then going down, so that's going to be negative 2. Okay, so we're okay with this point now. Let's proceed with the fourth key. So pi over 2 plus pi over 4. So that's going to be equal to 3 pi over 4. And then again, the point is at the midline, so therefore that would be 0 for the y. And then for the fifth point, again, this is 3 pi over 4 plus pi over 4. And so we now have here 4 pi over 4, which is just simply pi. And then going up here to the maximum level or the maximum value, which is at 2. Okay, so now I'll proceed with the graphing. Okay, so we have here 1, 2, 1, 2. Okay, I'll begin graphing the cosine function first. Okay, we have here 0, 0, 2. Okay, hold on. Let me just go ahead and label this. Okay, so we have here pi over 4, pi over 2, 3 pi over 4, and then pi on the other side, negative pi over 4, negative pi over 2, negative 3 pi over 4. Okay, this is 3 pi over 4. Okay, plotting the points now, we have that point, and then we have here pi over 4, 0, and then down here, going up there, and then up. Okay, so this is the graph of the cosine function. Okay, now if I'm going to continue on the other side, because once again, the requirement here is to graph from negative 3 pi over 4 to 3 pi over 4. Okay, so now I will have to have this point, and then over here, okay, and then this point right here. Okay, all right, so again, our task here is to graph from negative 3 pi over 4 to 3 pi over 4. So let me begin with the asymptote first, so which are the x-intercept of the cosine function, and then over here. Okay, and then we are going to draw those parabolic shape on those maximum and minimum point. Okay, there you go. So this would now be the graph, the green line only. Okay, this would be the graph of the secant function. Okay, all right. Okay, moving on to the next example. Okay, so for the next two example, what we're going to do is, now we do have now a given value for D. And remember, this has no difference with the value for D that we had from sine and cosine. Okay, that the value for D represent our midline. Okay, so the process is exactly the same thing. All right, okay, so I'll start. Since I'm working on Since I'm working with the cotangent, so therefore, when we are solving for the asymptote, then therefore, this is from 0 to pi, okay, since we're working with cotangent, okay? So we are solving from 0 to pi. Why 0 to pi? Because remember, the definition of cotangent is equal to cosine over sine. And remember, sine theta is equal to 0 is at 0 and pi. Okay, so therefore, we are going to identify the asymptote within 0 to pi. Okay, so between here we do have there pi over 2x and then pi. And then I'm going to multiply everything by the reciprocal of pi over 2 since we want to completely isolate the x here. So multiplying 2 over pi, 2 over pi, oops, that is pi. Okay, so now we have here 0 and then x and then less than 2. Okay, so therefore our first two consecutive asymptote is x equals 0 and then x equals 2. Okay, all right, next we now identify the period. Period is again, we have x2 minus x1. And C, we have here 2 minus 0, which is just simply 2. Okay? And then next, we now have to solve the increment. Okay, since we already have the period. So the increment would be period divided by 4. So that's going to be equal to 2 over 4, which is 1 half. Okay. All right. Now, since we do have value for D in this case, here's the value for D. So remember, this is the value for um, A. Okay. This is the value for B. And this is the value for D. Okay. That means to say we do have that midline. All right. Okay. So let me just go ahead and draw it here. So midline. So our midline here would be y is equal to whatever the value of d. So in this case, it is equal to 1. Okay. Now, not only that, we also need to find those quarter points within this asymptote. Okay, so let me name that as y1 and then y2 for those y coordinates from our key points within those two consecutive asymptotes. So this would be d plus the absolute value of a and then d minus the absolute value of a. Okay, so now we'll have here equal to 1 plus absolute value of A is 4. So this is equal to 5. And then this is 1 minus the absolute value of 4, which is negative 3. Okay? All right, so those are the y coordinates that we are going to follow when we are finding the key points. Okay? So let me go ahead now, find the keys here. So first, second, third, and then fourth, at least 5 key points. Okay, fifth point. Okay, all right. Now, our starting key, definitely our asymptote, which is x is equal to 0. Again, this is our first asymptote. Okay, second point, we will add that increment 1 half. So that's gonna be 1 half. And then the value for the y coordinate. Remember, we have solved that the first y coordinate is 5, okay? We're starting from above, even though um, what do you call this? This is a cotangent, okay? So now in this case, we have here um, negative sign. Okay. Let me just go ahead and review that. Remember the cotangent is decreasing. Okay, decreasing. Okay, so you can see here from the parent function. And since the value for A is negative, so therefore we are going to reflect that over the x-axis, okay? So instead of decreasing everywhere here, so what we are going to do is we are going to reflect that and that becomes increasing, okay? So we are going to start from this key points here and then on the midline and then that third quarter of the point within those two consecutive asymptote, okay? So remember, in terms of the y value here, remember this is negative 3. In terms of y value, this is 5, okay? So therefore, our first point here of the y value would be negative 3, okay? All right, next we have here now 1/2 plus the increment 1/2. So that's going to be 1/2 plus 1/2 is 1. And then we'll go up to the midline, and we know that the midline is equal to 1. So therefore, this is 1. Okay? All right, and then the fourth point there, that would be 1 plus the increment 1/2. So that's going to be 3 over 2. And then it's going up. We know that going up there, it will reach that um, third quarter. Sorry, yeah. Okay, so we'll have there 5. And the next one we have here 3 over 2 plus the increment 1/2. So that's going to be equal to 4 over 2, which is, again, just simply 2. And then remember, this fifth key here is our asymptote, which is x is equal to 2. Okay, which we have solved it in here. Okay, so now I have complete keys here. So I will now begin graphing the function. Okay, so now we have, okay, so now we are now going to, okay, draw the key numbers here. So we have here 0 and then 1/2, 1, okay. And then we have here 3 over 2. And then we have here 2. Okay. Now the problem here is that we want to graph this in for 2 periods. Okay, so I'm just gonna go ahead and extend that on the right side. So another 1, 2, 3, 4. Okay, we have there 2 and then another 1/2, so 5 over 2. We have 3. Oops. We have 7 over 2. And then we have 4. Okay, all right, now I'm gonna go ahead and start with our asymptote. Our asymptote is at x equals 0, and then we have here that x equals 2, and then also I am going to graph our midline. Okay, so our midline here, you remember this is y is equal to 1. Okay, y is equal to 1. Draw that. So 1, 2, 3, 4, 5. Negative 3 here. Okay, so our midline would be at y is equal to 1. Okay, all right, now plotting the points now, we have 1/2 negative 3, 1/2 negative 3 over here. And then we have here 1/2, sorry, 1/2 negative 3, and then we'll have here 1, and then 1. And then we have 3 over 2, and then 5. It's right up here. So there you go. Okay, and then I will just be copying exactly the same shape there with our first period, following it. Okay, making it the same on the second period. So we have it here, and then midline, and then add 5. Okay. All right, so there you go. So this would now be the graph of this given um, function. Okay, so as you can see here, we do have here the midline, which is the y is equal to 1. All right, okay. Now let me go ahead and proceed with the next example, which has everything, but in this case, we have here a secant function. And then remember, when we are graphing the secant function, we are just actually just graphing the cosine function, okay? So with this, we now begin um, by once again identifying the values that would graph a cosine function. All right, so I'll start with the amplitude, okay? Because as we can see here, we have the coefficient a here that is in front of the function, which is 2. Okay, so we have here the value for a, value for b, and then value for d. Okay, sorry, this is value for c. There you go. Okay, so let's start. Amplitude is the absolute value of a, so therefore this is 2. Okay, and then period, that would be 2 pi divided by b. We do not have value for b, so this is just, well, we do have value for b, which is 1, but that would be the same thing for the 2 pi, so 2 pi over 1, which is 2 pi. Okay, next we have the increment, which is period over 4, which is 2 pi over 4, which is equal to pi over 2. Okay, next one, we now have here the phase shift. So the phase shift would be C over B. Again, this is positive. That makes it a negative sign now. So negative pi over 3 over B, which is 1, which is a negative pi over 3. Okay. All right. Now, since we do have value for D, so therefore we do have value for the midline. So the midline here would be y is equal to d. Again, in this case, it's y is equal to 1. All right. So next, we'll have here the maximum point. We know that the maximum point is d plus the absolute value of a. So this is equal to 1 plus 2, which is equal to 3. And then the minimum value, which is d minus the absolute value of a, which is 1 minus 2, which is again negative 1. Okay? All right, now we'll move on with the key points. So the keys here, we will start with the first point, second, third, and then we'll have for the fourth point, oops, and then the fifth point. Okay, so the first point is definitely we will be having at 0. Okay, but since we do have there a phase shift, so our first x coordinate here would be a negative pi over 3. Okay, so which is this key point, phase shift right here. So therefore the first point here, remember this is a cosine function, so therefore we are starting at the maximum value. So if the x is negative pi over 3, so therefore this is negative pi over 3, and then maximum value would be equal to, let me just go ahead, maximum is 3. So negative pi over 3 and then 3. Okay, second point, we now have a negative pi over 3 plus the increment pi over 2. Okay, which now gives you a pi over 6. Again, remember the cosine function looks like this. Okay, we are at the maximum level, and then we'll go back with the midline. So therefore, the y value here would be 1. Okay, next, let's have the third point. We have pi over 6 plus pi over 2. So that's going to be equal to 2 pi over 3. And then down here with the minimum level, which is negative 1. Okay, all right. Next up, we now have 2 pi over 3 plus pi over 2, which gives you a value of 7 pi over 6. Pi over 6. And then going up here to the midline, so therefore that is 1. Okay. Next, we now have the fifth point. Okay, so we have there 7 pi over 6 plus the pi over 2, which gives you 5 pi over 3. And once again, going up to the maximum level, which is 3. Okay, now I do have my complete key points here. I will now begin graphing the secant theta. Remember, we are graphing two periods here. Okay. So it did not tell us whether we are graphing from a particular exact point or ending with a specific interval. Okay, so wherever the starting and then the ending point. Okay, so I'll be using the negative pi over 3 here. So we have negative pi over 3 at the point. Then pi over 6. Okay. 1, 2, 3, 4. All right, and then we have 1, 2, 3, and 1. All right, so I'll begin with the midline. We know that the midline is y is equal to 1. Okay, and then we have here the first point, negative pi over 3 and then 3. It's over here. And then going down, do it pi over 6 and then 1. Then going down here. And then going up. And then up there. Okay. So under cosine function, this is 1 period. Okay, and then we'll have here going down. I'll follow exactly the same path here or the same shape. Going up and then going up. Okay. All right. Now I'm going to go ahead and add one more point here. Okay, which will be an increment of pi over 2, which is 13 pi. I'm ending up my point here at 13 pi over 6. Okay, all right. I'll tell you why, so let me go ahead with that. Okay, all right. Remember, the asymptote here would be the point intersecting the midline. Okay, so this would now be our asymptote. Okay. Again, we are tasked to draw two periods. Okay, and then we are going to draw those parabolic shape to each of those maximum and minimum level. Okay, so as you can see here, the reason why instead of, well, you can extend it over here. Okay, and then create a parabolic shape on this side. In my case, I just extended on this side so I can have a parabolic shape on this shape on this portion right here. So as you can see, I now have here two period. Okay, my first period here and then second period. All right. Okay. All right. So again, this completes all the example for section 4.6. Again, today we just completed all our study of the six trigonometric functions. Um, Again, as you see that we have explored the tangent, cotangent, cosecant, and then secant. So again, as you continue practicing, make sure you can identify the following: the period, the domain, the range, and of course the symmetry, other even, vertical asymptotes, and then of course the key points. So these characteristics will help you graph any trigonometric functions with confidence, okay? All right, so before you move on to the next section, please make sure you complete the checkpoint problem on your own. Try to work through the entire graph independently before checking your notes, and then again, remember, I have mentioned this before, watching example is helpful, but real learning happens when you practice the process yourself. Okay, so take your time, use today's example as a guide, and make sure you are comfortable with transformation before moving on to the last section of this chapter, which is the inverse function in section 4.7. Okay, thank you for watching, and I'll see you in the next lesson.